Okay, for question 8, the derivative of function f has exactly 3 zeros. Which of the following could be the graph of function f? Okay, the derivative has 3 zeros, meaning the derivative has 3 critical values. We have well-behaved functions here. There's no discontinuities or anything. So if you look at this, you got to figure out which of these functions has a place where you could find 3 critical values. Critical values happen at the humps. So for instance, here's a hump right here and a hump right there, but this function won't work. It's only got 2. This one has a hump. It has a 0 right there because that's where it's flat, but this one only has 2. The only one that's going to fit for us is A, is the one with 1, 2, 3 humps. That's question 8. For question 9, we're going to look at this graph right here and figure out how many points of inflection it could have. Okay, or it has, I mean. Okay, it's a polynomial, so it's well behaved, it's nice and smooth. No bad things happen to it. So what we really need to do here is just look at the derivative. So f prime of x is equal to 40 x to the 4th minus 20 x cubed. And then remember, inflection points happen when the second derivative is 0. So let's look at 160x cubed minus 60x squared. Okay, when does this equal 0? Okay, let's see what happens if we factor it out. We end up with, looks like 20 times 8x cubed minus 3x squared. And let's take an x squared out too. 20x squared, where 8x minus 3 equals 0. So it looks like we have zeros here when x equals 0 or x equals 3/8. Okay, but now we really probably need to do a sign chart to figure out what's going to happen. So let's put the factors up here, 20x squared and 8x minus 3. See, the danger is one of these may not be an inflection point. So if you jump right away and circle 2, you might be getting it wrong. If x is 0 and x is 3/8 marks the places where our second derivative is 0, then what we need to do is divide our domain up into 3 sections based on those 0 values. And 3/8 to positive infinity. And then we use our sign chart analysis to figure out what the signs are going to be. So that's f double prime of x. Okay? When this is negative, or when x is negative, this will be positive. In fact, this will always be positive because we're squaring that term. When this is negative, this will be negative. When x is between 0 and 3/8, it's still going to be negative, and then it'll be positive. So what we've got here is a situation where the second derivative is negative, negative, and positive, and the only place that it switches signs is right here at 3/8. So that's going to be the only inflection point. This right here won't be an inflection point. And if you graph it, you can see that that's the case. So the answer to this is 1, only 1 inflection point. Okay, for question 10, let's see what we've got. We've got this graph of a derivative. Okay, that's really important, so make sure you see that. This is the graph of the derivative of g. Okay, so now they're asking us what's true about the function g based on what its derivative looks like. Let's see, g is increasing for x greater than 2. Okay, let's see. If x is greater than 2, the derivative is positive. If the derivative is positive, it means the function's increasing. So this one is correct. G has 4 points of non-differentiability. Let's see, is that true? No, that's not true. Okay, you might think that at the kinks it's not differentiable. Okay, that's not true based on the context of this problem. Okay, we're looking at the derivative. If g wasn't differentiable, the derivative wouldn't exist. But the derivative does exist at each of the corners because it's graphed. Okay, if we had a situation like this where g prime would look like that, then at this point it wouldn't, the function wouldn't be differentiable. Okay, so don't get confused between g not being differentiable and g prime not being differentiable. Certainly the second derivative of g won't exist here and here and here and here because of the corners. So 2 is out. Function g is not a continuous function. That's not true either. It actually is a continuous function, okay? Because the derivative is defined at all different places. So the function has to be continuous. So 3 is also not correct. So the answer here is 1 only. Only g is increasing for x greater than or equal to 2.